Okay guys, so here's this guide video. We need a calculator for this. So a particle moves along the x-axis with velocity given by this from time here, this interval. The particle is at position x equals -5 at time t equals 0. So they're telling you that x of 0 equals -5. Part A, find the acceleration of the particle at time t equals 3. So for part A, you need to know that acceleration, that acceleration at any time t is equal to the derivative of velocity, all right? So that means that the acceleration at time 3 is equal to the derivative of velocity at time 3. Now, in order to figure this out, guys, you want to use Math 8 in the calculator. All right, so I'll go, well, I want to make sure I'm in radians, which I am. Math 8. Okay, so that brings up this derivative thing. So we're doing so basically, I'll write it like this. So in the calculator, right, so we're going to do Math 8. So we're going to do dt of velocity evaluated at t equals 3. All right, so that's what we're going to plug into our calculator. But we got to use x's in the calculator. So 10 sine 0.4x squared evaluated at x equals 3. Okay, so right there. So this is equal to -2.118. All right, so that's the velocity, or no, the acceleration at time t equals 3. So part B, find the position of the particle at time t equals 3. So if you know the position, or if you know the velocity and you want the position, then you need to find the antiderivative, and you, in this case, want to use the antiderivative with an integral formula. All right, so for part B, the position at any time t is going to be the position at some time that we know, which I'm calling a, plus the integral from a to t. So whatever this variable is, that's where the input goes. So that's what that variable needs to be. And then in here, you do x prime of w dw. Okay. So x of t, this is what we know. X of 0 is -5. So I'm going to put x of 0 plus the integral from 0 to t. And then x prime of w, that's v of w, which we know v right there. Okay, so finally, I'm going to do x of 3 that's -5 plus the integral from 0 to 3 v of w dw. And now we're going to use Math 9. Math 9. Whoops. So Math 9 opens this up. Or actually, let me go, I'll go -5 plus Math 9, 0 to 3, 10 sine 0.4 . Okay, so -1.760. All right, so that's the position of the particle. All right, so this was the answer for A. Answer for B. Okay, now answer for C, we're going to evaluate this integral and that integral, and then we're going to interpret the meaning of each integral in the context of the problem. So, this is part C. All right, so first I'll evaluate from 0 to 3.5 v of t dt. Oh, you know what? I could just take this and hit enter again. So that's going to be, I want to change that to 3.5, and I think I can just delete all that. Okay, 2.844. 2.844. All right, so, yeah, and let me just find the other one. So this is the integral from 0 to 3.5, absolute value of velocity. So I think I just have to type this again. I don't know how to put, you know, like copy and paste and put the absolute values in. So you go math over to number, absolute values. So 10 sine 0.4 it's just taking a minute. Okay, 3.737. 3.737. All right, now they want us to interpret the meaning of each integral in the context of the problem. So let's think about the context of the problem. A particle is moving along the x-axis with this velocity. Guys, if you take the integral of velocity, that gives you the net change in position, which is the same thing as displacement. So, so I'll say it like this. I'll say this is, evaluate this, interpret the meaning of each integral in the context of the problem. All right, so this is, I guess I'll say the net change in position from t equals 0 to t equals 3.5 is 2.844. All right, and guys, net change in position, you could also say displacement. And actually in their answer key, they say displacement, okay? So the displacement from t equals 0 to t equals 3.5 is 2.844. All right, and then here, when you do the integral of the absolute value of velocity, you get the total distance traveled. So the total distance traveled from t equals 0 to t equals 3.5 is 3.737. Okay, guys, now we just got part D. So part D. So a second particle moves along the x-axis with position given by this for this time interval. At what time t are the two particles moving with the same velocity? So this is the velocity of the first particle. This is the position function of the second particle. So we've got to take the derivative of this and set it equal to that. All right. So, so this is part D. So I'll just say the velocity of particle 2 at time t is x, is this, the derivative of that. So that's 2t minus 1. So now I'm going to take 10 sine 0.4 t squared over t squared minus t plus 3, set it equal to 2t minus 1. All right, so this is 10 sine 0.4 x squared all over 2 minus 1. All right, now the interval we're on is 0 to 3.5. So I'm going to go to my window, 0 to 3.5. All right, then my y-mins, I don't even know. I'll go negative 10 for the lowest y, and then 10 for the highest y. And let's see. Okay, so there's the velocity graph for the first particle. And there's the velocity graph for the second particle. And I just got to find their intersection point, which is like right there. So I go second calc, intersect, and there it is. Okay, so t equals 1.571. Alrighty.